Hello everyone, let's solve Leetcode problem number 242 valid anagram. So what does the question says? It says given two strings S and T, return true if T is an anagram of S and false otherwise. So let's understand what an anagram is. An anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all the original letters exactly once. So what it's saying is, let's understand it through an example. So we have a string S, A-N-A-G-R-A-M, and we have a string T, N-A-G-A-R-A-M. So here we can clearly see that the string T is just a rearrangement of the letters that we have in string S. So we have exactly the same number of A here. So 1, 2, 3 A's, 1, 2, 3 A's here. 1 N, 1 N, 1 M, 1 M, 1 R, 1 G, 1 R, 1 G. So we have exactly the same letters, just rearranged in a different way. So these both are anagrams, whereas in this example, rat and car, so we have R used once, A once, A is once, but here we have T, and here we don't have a T, and here we have a C, and here we don't have a C. So these two are not anagrams. So how do we solve this particular problem? So already, as we discussed the logic to understand the definition of anagram, we can exactly use that. What we can do is we can just count the number of alphabets that are there in both of these letters, and if they are exactly the same, so there's no extra characters being used, or whatever the characters are being used, they are being used the exact number of times, exactly the same number of times, then we'll say that both of them are anagrams. So what we could do here is we can count the number of A in this particular string. So A here is appearing 1, 2, 3 times, right? Then let's say we do N. So N here is appearing 1 time. And then G is appearing also 1 time. R is appearing 1 time. M is appearing 1 time. Okay, so this is for anagram. And then similarly, what we do is we count the number of letters that is appearing in this string T. So we have A appearing 1, 2, 3 times. We have N appearing 1 time. We have G appearing 1 time. We have R appearing 1 time, and M also appearing 1 time. So now if we compare this character count here with the character count here, then we can see that they are exactly the same. So we can say that both of these are anagrams. Okay, whereas this, I'm just putting here a comma. So whereas in this case here, in both of these strings, so we have rat and car. So R appears one time, A appears 1 time, T appears 1 time. Okay, and in this particular string, C appears 1 time, A appears 1 time, R appears 1 time. So this is the character count here. And now if I compare this character count with this, so this is obviously different. Since we have C here 1 time, we don't have a C here, we also have a T here, and we don't have a T here. So both of these are not anagrams. So in Python, what we can do is, so we want to use a hash table here, right? Where key will be the characters and the values will be the count, the number of times the character is appearing in that particular string. So in Python, we can use a dictionary to store keys and the values. So we can have 2 different dictionaries. So one for string S, one for string T, and in the end we can just compare both of them, and if both of them are the same, both of them are equal, then we return true, else we return false. So this is what we are going to do. And one more thing just in the beginning that we are going to use is that, so if both of these strings are anagrams of each other, then they have to be of the same length, right? Since we are using the same number of same characters just rearranged in a different way. So if they are anagrams, then they have to be of the same length. So if they are of different length, then we can just directly return false. So let's write the code for this part. So what do we do? So we have string s and we have string t. So the first thing we can check is if they are of different length. So if length of s is not equal to length of t, so what does this mean? So this means that they are of different length. So they are for sure not anagrams, right? So we can just return false. So if they are of the same length, then what we can do is we can have two different dictionaries or two different hash maps. So char count s. So this is our first dictionary where we will store the character count for the string s, and then we can have one more dictionary, char count t, where we will store the character counts for string t. And now what we can do is we can go through all of the characters. So for I in range, length of whatever s or t, it does not matter since both of them are equal. If they are unequal, then we already return false here. So for I in range, length of s, so what we do is we do char count underscore s. So in this dictionary, so we want the key as s of I, right? So the character at that particular position. And what we want to do is if this key is already there in our dictionary, then we want to get the value of that key and add 1 to it, right? But if that key is not there, it is not present in the dictionary already, then we would just want to add 1 to it, right? So what we'll do is that we'll do char count underscore s, and there is a method called .get. So what this method does is that if it finds this particular key in this dictionary, then it will return the value of that key. But if it does not find that key, then we can set a value that it will return. So we want to return 0, right? And then we add 1. So what this line is doing is that it will check in this particular dictionary whether this key is present or not, s of I. So if the key is present, then it will return the value of that key, and it will add 1 to it, right? And then it updates the value of that particular key. Whereas if that key is not already present in the dictionary, then it returns 0 and just adds 1 to it. So that will be for the string s. And now we want to do the same thing for char count underscore t as t of I. So now we want to access the string t, and we can repeat the same thing. So char count underscore t dot get t of I. And again, if we don't find the key, then we return 0. If we find the key, then we return the value, and then we just add 1 to it. And now we have these two dictionaries or these two hash maps, and what we want to return is we want to compare both of these, right? So if both of them are equal, then we want to return true, else we want to return false. So we can just compare both of these. So is char count for s equal to the char count for t? So if both of these are the same, then it will return true, else it will return false. So let's submit it and try to see what's happening. So now let's submit it. And we can see that the solution is accepted. Okay, so this is a very easy solution that we can use. Now for optimization, what we could think about is that instead of using two different dictionaries, we could also just use one. So what we can do is that we can just use one dictionary and build that dictionary for string s. And for string t, what we can do is that for every character, we can just look if that character is present in the dictionary or not. If that character is present, then we will just decrease the value by 1, and we will always keep checking. If the character in T is not present in the dictionary for S, then we will return false, or else we'll also check if the character count is 0, then also we'll return. So I think this will be better explained if we just directly code it up. So I'll just change the name of this solution, so class Solution1, and let me just write an alternate solution that we can use. So instead of using 2 dictionaries, we can just use 1. So the first part remains the same, that we still check for both of the lengths not being equal. So if the length of S is not equal to length of T, then we return false. Okay, and now what we want to do is we want to use just one dictionary. So let's say we just use for the string S, so char count S, and now this time we want to build it up just for the string S. So let's say, so for char in S, so we loop through all the characters in this particular string and we repeat the same thing. So char count underscore S char, and we do the same thing, that we check if this character is already present in the dictionary. So if it's already present, then it will return the value, else we will return 0 and we will add +1 to it. Okay, so what this for loop will do is that it will build up the dictionary for the string S. Now what we want to do is, instead of using another dictionary for T and then comparing it in the end, what we want to do is we want to just loop through the characters in the string T. Okay, and now what we want to do is we want to check if this character is not in. So if character not in char count S, right? So the dictionary that we have built, so if this character is not present in that dictionary, meaning that this character is only present in T. So if that is the case, or if we check for the value of this character in the particular, in this particular dictionary, so if that is equal to 0, so you will see when it gets to 0. So if that is equal to 0, this means that they are not anagrams. So why is this happening? So if the character is not present in character in the dictionary for S, then obviously this character is only present in T, so that's why we want to return false. But if the character count in this dictionary is 0 for that particular character, then also we want to return false, right? So if that is not the case, so for character in T, so if this is not the case, then what we want to do is we just want to take the char count S for this particular character, and we want to decrease that value by 1, right? So what this will do is, for every character that we find in T, so if it's also present in S, then it will just decrease the value by 1, right? And the next time if it again comes there, the original value will be 0, so it will return false. Okay, and if it goes through this for loop and it doesn't encounter any such case where the character is not present in the original dictionary, or the value for that character is not 0, so it will run through this complete for loop. So in the end we can just return true. Okay, so now if I run this, so since we have this as solution, so now it will accept this particular solution, and we submit it, so this also accepts, right? So in this case we are using just one dictionary instead of 2. So now there is one more solution that we can think about, that we could possibly have for this particular problem, is that, so let's say we want to check both these strings whether they are anagrams or not. So what we could do is that we could write this string in a sorted order. right? So let's say in the ascending order from the smallest alphabet to the largest. So we write this particular as A, 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 right? So A, and so A, B, C, D, E, F, G, H, I, J, K, L, M, N, and R, right? So this will be its sorted order, right? And then we can again sort this as well. So it will again be A, right? And then we'll have G, and then we'll have M, we'll have N, and then we'll have R, right? So if we sort this particular string and we sort this string, then if they are anagrams, so they are using exactly the same alphabets and they will get sorted in the same order. So both of this will be equal, right? So we can just sort S, we can sort T, and we can compare both of them. So if both of them are equal, then we return true, else we return false. And in this case, we can check if we just sort this, then what do we get? We get A, R, T, right? Whereas in this case, we'll get A, C, R. And if we compare this, then they are not equal. So we will return false in that particular case, right? So in this case, what happens is that there are some sorting techniques which does not use extra space. So this will have like this is not using any extra space, but the best that we can do with sorting is O of n log n, right? So the solution will be n log n, whereas in the beginning what we were doing is we were using extra space, but the time complexity for this was n, order n, big O n, right? Because we were going through the string just once, right? So let's write the solution for the third part. So this I'll just call solution 2, and class solution. So let me write for the sorted. So class solution, and in this part, what we will do is it's just one liner here. So return sorted S is equal to sorted T, right? So this will, if after sorting both of them are equal, then we will return true. If after sorting both of them are unequal, then we return false. So let's submit this particular thing here. And yeah, it does well, but yeah, here we can see, so this sorted method actually uses extra space. So this does not really do well here. So in Python also, like, it depends. So when we use dot sort method, then it does not use extra space, whereas sorted will use extra space. But yeah, this is just another method to do it. But the runtime, as I said, this will be O n log n, whereas the runtime of the above methods that we did will be O of n.